Events in C Sharp. What are events and how and when should you use them? Events are particularly useful when you have an object that you don't want to constantly monitor, but you need to know when something happens in that object. Imagine a user interface, for example, with tick boxes and buttons, etc. You don't want to constantly loop through all the controls to check if their status has changed or a button was clicked. You want your code to continue normally, and when something happens, it gets notified by the control. For example, a button can at any time notify the rest of your code that it was clicked, and you can now respond to the event. Another example, imagine a spacecraft with millions of sensors. Instead of constantly looping through all sensors and checking their status, your system can just wait for an event to happen in a sensor and respond to it. How does this work? You have a publisher class that will invoke an event. In this example, we have a traffic light object that will invoke the event turn light red when it becomes red. On the other end, you can have 1,000 or more car objects listening for the event. These are your subscribers. Back in the traffic light object, there's a delegate. This is just a list of all the methods it should execute when the event is fired. So in simple terms, if a car object wants to listen or subscribe to the turn light red event, it adds its own response method to the delegates list. The same when it wants to unsubscribe to the event, it simply removes its method from the event. We'll use a normal console app project for the demonstrations and use the .NET 9 framework. We're going to add 3 simple classes: an order object that creates an order and generates an event, an invoice object that responds to the event and simulates generating an invoice, and an email object that responds to the orders event and simulates sending an email to the customer. The email class has a send email method that takes an order ID argument and simply notifies that an email was sent. The invoice class has a generate invoice method that also takes an order ID argument and simply notifies that an invoice was created. Of course, in a real-world app, these methods would actually perform the tasks. But take note of the signatures of the methods that will respond to the event. Both take an order ID as argument. Then in the orders class is where the event will be invoked from. First, we need a delegate that will hold all the methods that needs to respond to the event. Again, notice that it needs to have the same signature as the methods that subscribe to the event, an order ID argument. We create an event that is of the delegate type. Then we have a method that's going to fire off the event. It simulates creating an order. Then if there are subscribers to the event, it invokes the event and passes the order ID to the subscribing methods. In the main program, we create an orders object and add the email and invoice methods into the event. It uses a lambda expression and says, use the order ID from the orders object, then create the object we need and execute this method of that object, passing the order ID into it. This means the delegate in orders has now got 2 methods subscribing to the event. When we call the place order method in orders, the event is invoked and the email and invoice methods should respond to the event. Next, we're going to look at the event handler. The event handler is a built-in delegate provided by C#. We have a traffic light class that fires an event when the light changes to red. Instead of defining your own delegate, you can simply use event handler. Its signature has a sender, which is the object sending the event, and event arguments, which hold status of the event. The drawback is that it cannot hold any custom arguments that you want to send to the responding or subscribing objects. This is a quick way to notify the subscribing objects that an event occurred without passing data to the responding objects. In the changelight method, we invoke the event if it has any subscribers and give the parameters the arguments of this is the object sending the event, and there's no other event arguments required. On the receiving end, we have a vehicle class that responds to the event when the traffic light changes to red. Its signature matches the event handler delegate with a sender object and event arguments. Just to be fancy, we pass a vehicle name into the class constructor and use it to indicate which vehicle needs to stop. In the program class, we commented out the previous lines of code and created a traffic light object and a vehicle object called myCar. Then the car object subscribes to the traffic light object's event by adding the car's traffic light is red method to it. When we call the changeLight method in the traffic light object, the car responds to the event. But what if we do want to send custom data through the event arguments to the subscribers? We can create our own version of the event arguments. Here we added a CS class and called it something like Event Arguments Extensions. Inside, we created a class called Traffic Light Event Arguments, and it inherits from the Event Arguments class. All we needed to do is add the custom property we want to send to the event subscribers. In the traffic light class, we tell the event handler to use our new traffic light event arguments instead of the default event arguments. In the method that's going to change the light color, we can now pass it the color of the light we want. Then we define a traffic light event argument and set our special property to the light color. Now we can pass our custom event arguments when invoking the event. In our vehicle class, we change the method's signature to match the new event handler's signature by using the traffic light event arguments. Then we check our special property and respond accordingly. In the program CS class, we still add the subscribers method to the traffic light events delegate. But now we can change the color of the light when invoking the event, and our vehicle will respond to the color. So far, the subscriber methods in the delegate fires off synchronously, the one after the other as they were added or subscribing to the event. But what if we want those methods to be executed asynchronously so they don't lock up the system while they're executed? So for the second part of this video, we're going to look at adding and executing asynchronous subscriber methods. It's a bit trickier, but we'll take it step by step. We'll add a class called Async Sensor, which is the publisher that will invoke an event. Our first step is to add a delegate. It's important to use the task keyword when defining our delegate because every asynchronous method in the delegate will be a task. We're using a very generic form here where we say it can accept some type of event argument parameter. It's not necessary to be this generic, but it serves as an example of a generic delegate. Next, as normal, we declare an event of that delegate type. Here we specify that our event arguments type is sensor event argument. This we declared in our event arguments extensions file. We created the sensor event arguments class, which inherits from event arguments, and added the properties we want our sensor to share with its listeners. Back in our sensor class, we have the method that will raise the event. It will take arguments that will be used in the sensor event arguments. Then, if the event is not null, meaning it has subscriber methods in its delegate, it continues to create a sensor event arguments object and populate its properties with the arguments we pass to the method. Now the tricky part comes in. We need to get a list of all these methods or handlers so we can execute them with await statements. We use the invocation list and cast each handler to the list. Then each of these handler methods must become a task. We could execute each handler in a try-catch block and keep track of errors that occur in the subscribers. Personally, I feel this violates separation of concerns, and the publisher shouldn't be aware what the subscribers are doing with the event. But this is up to you. You can simplify it like this and let each subscriber method deal with its own exceptions. Either way, the last step is to await all these tasks, which, as we demonstrated, is just a list of methods that will handle or execute when the event occurs. Notice there's no more invoke statement because we already got all the handlers from the invoke list above. It's not the most intuitive code, but with careful consideration, the logic will become clearer. Of course, in our subscriber objects, the methods we'll be adding to the sensor's delegate need to be asynchronous methods. Here we used our fancy sensor event arguments class to print out the sensor's name, alert level, and alert message. In the Program CS class, we create our sensor and two responder classes. We subscribe to the sensor event by adding each responder's handler method to the event. Then we raise the sensor's event using its raise method and pass it an alert level and alert message. As a result, the two subscribing responder objects respond asynchronously to the event and prints out the details of the event for us. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.